everyone, welcome to duodecimal division. My name is Eric Larson and this is the first video in a series of videos that I'm calling the secrets of the numerals. What I'm going to be doing in this series of videos is explaining to you how someone has used this particular geometric pattern to come up with all the various designs for the various numerals. So what we're going to be doing in this video is looking at the numeral that represents the number 1 and analyze why it has the distinctive shape and qualities that it does. But before we get to that, I just want to show you how to actually draw this diagram, how to actually create it with the various shapes and lines so that you understand more clearly the inner workings of this diagram, because it really is foundational to this entire series of videos. All of the circles that come later are going to be generated, their radiuses are going to be generated from this pattern. So this is a very foundational pattern. When you're interested in geometry, it's really great to know how it works. So I'm going to show you how to draw that right now, and then we'll get into the qualities of the numeral that represents the number 1. Okay, so here is the series of steps that you need to take to get to this diagram right here. And from here we go back to the grid that we were just looking at, and we can keep building it more and more. So what you need to do is just get your compass. All you're going to need is a compass and a straight edge, and you can either draw this diagram on blank paper like we have here, or you can use graph paper. And if you decide to use graph paper, it's great if you set your compass to the distance of 12 little squares, so that then you'll be creating a diagram that's actually on a base 12 grid. And then if you're following along, you can see how some of the numerals, it's really relevant whether you're in base 10 or base 12. Okay, so I like to draw a line first and put my compass on that line and then draw my first circle. And that way I get 2 more points right away. And I've also established my x-axis. Sometimes it's not so easy to get it straight, if that matters. So when you get to this point, maybe if you didn't have your line, it might be a little bit tilted one way or the other. I don't know if it matters. But either way, you draw your first circle, then you put your compass down on the edge of that circle and draw another circle. And you just keep doing that pattern, and everywhere where the circles intersect, you put your compass down there and draw another circle. You just keep doing that. You're going to work your way around the first circle until you get to this point, and then you start connecting your points with lines. So you have your x-axis, and here we have the 2 points to draw our y-axis. And once you get to this point, you now have created the heart of your Cartesian plane right there. And now we've got some more new points on the original circle, where we put our compass down and draw 2 more points. Then we get to this point here. We've created 4 more points on our original circle. We draw 4 more lines, or 4 more circles, and we get this pattern right here. So now we've got all these patterns that we can use to start creating straight lines by connecting those various points. So the first thing we do is create lines that go through the center. So now we're creating degree lines. And after we've completed this step, we've created 24 dissections of the original circle. So the original circle at this point has now been divided into 24 equal sections. And not only that, all of the other circles around that circle have been divided up equally into 12 sections. So there's a lot of geometry happening within this pattern, and it's all been generated just by drawing circles and then connecting the points with lines. So now we can keep connecting the points with various lines, and we can start drawing more horizontal lines and vertical lines. Now we're taking more steps into creating the Cartesian plane, and we can also start connecting again, all the same points, but we can change the radius on our compass a little bit larger, and we can draw a circle with the radius of the square root of 2. Then the next series of points, the next ring, is a circle with the radius of the square root of 3. And then this last circle that sort of encapsulates the whole pattern is a circle with the radius of the square root of 4, which is the same as 2. So this pattern here is really the heart of the entire diagram. And we're going to use the square root of 3 and the square root of 4 and these lines to generate the points for all the rest of the circles. The square root of 5, square root of 6, square root of 7 radius circles will all be generated from using this point, drawing lines that go up in both directions, and finding the points that define the next circles in the series. So that's how you draw this pattern. So now we're going to go back to the diagram I was just showing you, and we're going to look at why the numeral that represents the number 1 has the shape that it does. And actually, I just want to point out right here, our very first step, we have one circle, we put the compass down on the edge of that circle and draw another circle. That's our first step. And so in relation to the numeral that represents the number 1, that's it. That from that first step generates the pattern or the bones of the structure, again, that represents, or that's where the numeral for the number 1 comes from. And I'll show you what I mean right now. All right, so now we're back to that geometric pattern, and I'm using a larger version now because we're talking about one of the smaller numerals, so I wanted you to be able to see clearly. So I've gone over 2 of the circles with the radius of 1. Here's our first circle, and we put a compass down on the edge of that circle and draw another circle, and you can see the 2 points where they're intersecting. So now what I'm going to do is go through the steps that I'm going to go through for all of the numerals. We're going to look at the lattice points that define the radius of the first circle, the one that we're looking at. So we're looking at this circle here with the radius of 1. So one of the lattice points that defines that circle is the center point right there. And then another one is this point right here. So I'm going to mark that one there. And I'm just going to draw a line between those 2 points. So there we go, just like that. And so right away, we have a length of 1 incorporated into the numeral. Now I realize that with the number 1 and the numeral that represents the number 1, 1 doesn't seem so impressive right now, but again, all the numerals contain the value of the number that they represent. So here we're consistent. We have a numeral that is the length of 1. So now what we're going to do is mark this point here. Again, another point that's defined by the circle and its relationship to this other circle. And the grid itself, we have a degree line going through there. So what I'm going to do now is trace this part of the circle that is intersecting that circle, and we have a shape that looks like that. And this is actually the symbol that represents the number 1. So now we're just going to look at some of the qualities of this symbol as it relates to geometry and the foundational elements of geometry. So first of all, we have a symbol that is encapsulating the relationship between the straight line and the circle. Again, we're starting off, this is the basics, so they're saying, hey, look at straight line and circle, that's what we're talking about. That's just geometry. The essence of geometry is the relationship of the straight line to the circle. And we have 2 points, and both of those points are the distance of 1 from the center point here. So again, how the 1 relates to the straight line and the 1 relates to the circle. And we've also defined this space here, this kind of empty space between them. And if we look at that space in relation to the complete circle, we realize that that is a section of, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to say dec, L, and do, or A, B, and then 10. But either way, that is 1/12 of the entire circle, which in base 12 we can convert to decimal and say that is 0.1 of the entire circumference of the circle. So we have the length of 1 and also the section of 0.1 of the circumference incorporated into this symbol. And then we also have this arc of the circle of the radius of the square root of 1 as well. So what's interesting also about this symbol is if I slide it over, here we go, to this point here, we see that now this straight line is landing on the point where the square root of 2 comes along. So we're also, again, foundational aspect of geometry. We've got a line that lands on the next circle in the series, and this point here is also landing on a relative point. So we have the gap here where that 0.1 becomes also the gap between the circle with the radius of 1 and the circle with the radius of the square root of 2. And we realize as we keep sliding that over, these 2 points are always landing on square root radius circles. If I do that again, you can still see that here, yeah. Now this point would be on the 5, and actually I'm going to show this to you on the other diagram so you can really see clearly. And now there's 2 rings between this point here, and again, this point is landing on 1 of the square root radius. Now it's the square root radius 3 circle. So that's something else that's very foundational in terms of the design of that particular numeral. Actually, I'll do that now. I'll convert back to the other diagram, and you can see more clearly how, as it goes along, it's always landing on specific lattice points and specific points where the circles are intersecting each other. Okay, so here we are with a smaller version of the pattern, and you can see again the placing of that symbol, how the one side is touching down on a lattice point and the other side is touching down on one of the other square root radius circles. So here it is, the 1 and the square root of 2. Then I slide it over like I did before, and now we're on the square root of 5 and the square root of 3. So there's 2 rings between those 2 points. And as I slide it over again, now we're on the square root of 10 and the square root of, let's see, 4, 5, 6, 7. So 7 and 10, so there's 3 rings between these 2 points. And as I slide it over again, the points are lining up on specific rings of the circle and lattice points. We have 4 of those rings between the 2 circles, or between the 2 points. And here on where the X has the value of 5, there are 5 rings between those 2 points. So again, a very foundational shape, kind of showing an aspect of geometry. And we've got a symbol that is the length of 1 and incorporates a lot of information about, the quality of 1 in relation to the circle. Okay, so that's it for the numeral that represents the number 1. Now we're going to go to the next circle in the series, next video in the series, and we're going to look at why the numeral that represents the number 2 has the distinctive shapes that it does. So I hope you enjoyed this presentation and that you can join me for the next one. Thanks for watching.